Yo, what's up, YouTube? It's your boy JOHHABRAHAM. We back. We big back. I got like 1 hour before, 2 hours before the oral exam starts. It's a fucking bee. Whoa. Please just kill yourself. Stop. Go away, gang. You don't want to mess with me. Just a minute. What is it doing? Just go away. Lord have mercy. Yeah, just go away. Fuck. I could murder. I could commit murder, but I don't want to commit. Please, just get the fuck out of here. Whew. Gone. It's gone. Yo, I'm done. I'm done with all of this. Fuck. Insects, man. I don't know why, but it's just no racism, but it's just no living organic for no living thing phobia or something, but insects just weirds me out. The goal of the experiment is to determine copper and 2 plus ion in an unknown sample using indirect redox titration. Unlike direct titration, copper ions react with an excess of iodine to release iodine, excess of iodide to release iodine, which is quantified using a standardized titrant. Sodium thiosulfate is now the primary standard. You first determine its exact concentration using potassium iodate. The iodide reacts with the iodide in an acidic environment to release precise amount of iodine through triplicate standardization. Yo, somebody just wrote me morning. Vibe of. What's up? Morning. Morning to you, lad. How you doing? I got like 2 hours and I gotta figure this out. Through triplicate standardization, you found the mean concentration, liberation of iodine. You added excess potassium iodide to your acidified copper sample. The copper ions will oxidize I minus to produce molecular iodine and off-white precipitation. No college or what? I got my oral exam in like 2 hours. So, yeah, that's it for today. Oh, you know what's the worst part? After this oral exam, I might go straight to sleep. You titrated the liberated I2 with your standardized thiosulfate. The thiosulfate reduces iodine back to iodide ions. So you add potassium iodide to your copper sample. Copper sample oxidize iodide anion to produce molecular iodine and off-white precipitate copper iodide. You titrate the liberated iodine with your standardized thiosulfate. The thiosulfate reduces the iodine back to colorless iodide ions. Because the reactions balance out, there's a 1:1 molar ratio. Oral? Yo. No. It's oral and analytical. It's not just oral, gang. Determination of copper to ions by aromatic titration. Ions by iodo. Analytical. Metric. That's something else. What if you could... No. I should focus on this one right now. The goal is to determine the mass of Cu3 plus ions in an unknown sample using an indirect redox titration. So first we measure the potassium iodate used, volume of titrate used, the number of moles, from the number of moles of is 1:1 ratio, so sodium thiosulfate. Then we figure out the concentration. The next one is volume thiosulfate used, number of moles, number of copper ions, mass of copper ions, molar mass, no, mass of copper ions in 250 milliliters. Then yeah, we got the mean mass in fucking 95% confidence interval. Let's move to EO5. Bismuth, it was pretty easy though. Okay. I got like why do I have to mention that to an AI? Maybe AI is gonna be like, oh, this guy has exam in like 2 hours. Oh, I better lock in. I better lock in. I better lock in. The titration, you're removing into the world. What? You're moving into the world of coordination chemistry. This experiment is faster than your previous ones. Shut the fuck. I think we use automatic piston burette. That's another important factor. This is a complex symmetric titration using EDTA. The critical role of pH. Before starting, you measured the pH of your solution and found it to be approximately 2 to 3. Why so acidic? The bismuth ions are very sensitive to pH. If the solution is not sufficiently acidic, the bismuth ions will react with water to form insoluble bismuth hydroxides or oxosalts, which would prevent them from reacting with EDTA. This low pH also makes the titration selective for bismuth, as many other metal ions cannot form stable complexes with EDTA in such high acidic conditions. Indicator silanol orange, spatula tip of search the free indicator dissolution instead of silanol orange bonds with bismuth effect to form bismuth indicator complex, which is red in color. Endpoint yellow. Could you explain why exactly is this complex able to change color? Also, xylenol orange. The fuck? Okay. You just ignored bismuth. The color change observed is caused by displacement of indicator from the metal ion. This transition from red to yellow is driven by relative stability of the complexes formed and the electronic environment of the indicator molecule. Bismuth indicator complex. So right after bismuth leaves from the indicator complex, it just goes back to yellow. Protonated form of xylenol orange naturally appears yellow. Okay, whatever you say, bro. What's the next one? Bing bang bada bing bang bada bing bada boom. Bidi bing bada bing boom bada bom bom bidi. Bom bom bada bing. Bada bom bom bing bing. Bom bom bidi bang bong bidding. Okay. Oh Lord! The determination of water hardness. So second complex symmetric titration using EDTA, but it differs significantly from bismuth experiment in the chemical experiment, and the specific ions measured. Here's a summary for your oral exam. The goal is to determine the total concentration of alkaline earth metals in a water sample. Total concentration of alkaline earth metal ions. The result is expressed in two ways: millimoles for cation, the German hardness degree. The reaction, like bismuth EDTA, forms a stable soluble 1:1 complex of these metals. Stoichiometry. This means every mole of EDTA you add responds to 1 mole of hardness causing ions in the flask. Basic environment. This is a major point for your exam. Why ammonia? In bismuth experiment you needed very acidic. However, from water hardness complexes with calcium or magnesium only form and remain stable in basic environment. The additive. You add 1 milliliter of concentrated ammonia solution to each 25 milliliter aliquot to raise the pH to 10. This ensures EDTA can bond effectively with metal ions and indicator functions correctly. What did we add? Concentrated ammonia. The indicator buffer tablet. Instead of the liquid or powder, use specialized. Okay. When you add a sample containing PS10, the indicator binds to small amounts of the metal ions to form a complex that remains brown. As as you add EDTA, it steals the calcium magnesium from the solution. It eventually pulls the ions away from the indicator complex because the metal MD EDTA's bond is stronger than the metal indicator ion endpoint. Once the last metal ion is removed from the indicator, the free indicator is released. In this specific basic environment, the free indicator appears green, signaling the end of titration. Devoted it. Good morning, dear Josh. Yo, what's up, devoted it? Good morning indeed. Your results and statistics. Okay, I don't think that's really important. Okay, next one. 6, 7. Oh, 6, 7? 6, 7? No. Determination of chloride content by potentiometric titration. Potentiometric precipitation titration. Oh no. I know they're gonna ask this. The goal was to determine the mass of chloride ions in the sample using argentometry. Oh, it's a name for that. Silver-based titration, argentometry. This is a precipitation titration where the analyte and titrant form insoluble solid. Chemistry and stoichiometry. The reaction. Silver nitrate reacts with chloride to form a white precipitate of silver chloride. Stoichiometry. The reaction is 1:1, meaning the number of moles of AgNO3 used equals the number of moles of chloride in your aliquot. Reaction is 1:1, meaning the number of moles of AgNO3 used equals the number of moles of chloride in your aliquot. Whew. Oh. Yo, somebody just used the chat and said like and subscribe. Like and subscribe, you're goddamn right. Like and subscribe indeed. This is precipitation titration where the analyte and titrant form an insoluble solid. Why the analyte and titrant form an insoluble solid? I don't remember. I remember. Yeah, I don't remember. Using the machine and just fucking white, fucking solid, fucking. How many times can I say fucking in a sentence? Yes. Figgity fuck fuckity. Figgity fig fuckity fuck. 7 o'clock. Wait, I had something important. I had one important thing. Just a minute. I have a really powerful morning drink. technical nuance and theoretical calculation. The goal was to determine, unlike previous titration where you used color changing indicator, this experiment uses an electronic sensor. Instead of looking for color change, metro system measures the electrode potential voltage of the solution. As you add AgNO3, the concentration of the free Ag plus ions changes. At the equivalence point, there's a sharp, sudden jump in potential. Your results show this happened approximately 374 to 384 millivolt. The instrument uses two electrodes to measure the potential, indicating the electrode, a silver rod. It is sensitive to concentration of Ag plus ions in the solution. Reference electrode. This provides a stable constant baseline potential against which the silver electrode is compared. You add 2 drops of nitric acid. This ensure the solution is acidic, preventing the formation of other insoluble silver salt, like silver carbonate, that could interfere with the results. Near the equivalence point, the titration speed must be slow. This is because the chemical equilibrium of precipitation can be slow to reach you as approach the endpoint, and a fast addition would lead to an inaccurate reading. God damn. You used Nernst equation to calculate what potential should be at different stages. The comparison. Your experimental equivalence point volume was approximately 3.22 milliliters, which aligned closely with your theoretical calculation. Results and statistics. Your results were explicitly precise for the. Shut the fuck up. Shut the fuck up. I don't care if it's precise. Who's doing the math? What exactly makes this happen? Summary on the whole. Encoding overloaded. What happened? What's wrong with the encoder? Like what's running so much in the background? Maybe it's a GPT? Could be. Could be ChatGPT. Before the equivalence point, the flask contains an excess of chloride ions because chloride almost every Ag plus ion you add from the burette immediately precipitate. The concentration of free Ag plus remains extremely low because of the excess Cl percent. As you approach the equivalence point, the concentration of Cl minus drops towards zero. At equivalence point, all Cl minus has been precipitated. The very next drop of AgNO3 no longer removed by precipitation stays in the solution as free Ag+. This causes concentration of free silver ions to increase to several orders of magnitude immediately. Okay. Because the Nernst equation is a logarithmic function, the massive relative increase in silver concentration causes sharp, sudden jump in the voltage from approximately 300 to 400 that the instrument detects as the endpoint. Summary of the theoretical calculation part. The additional task required for you to mathematically model the titration curve to see how closely your experimental data matched chemical theory. The calculation framework. You calculated specific points on the curve representing different stages of titration, concentration of remaining chloride, and then use the solubility product to find the tiny amount of that could exist in equilibrium. You determined the concentration of remaining chlorine and used solubility product to find the tiny amount of Ag plus that could exist in equilibrium. At equivalence 100% at this point. Ag plus and Cl minus are equal based on the KSP. You calculate Ag plus concentration to be exactly 1 in the 10 raised to 5 mole. At equivalence at this point, concentration of Ag are equal. So the concentration to be exactly 10 raised to 5. After equivalence, the concentration of Ag plus based on the excess AgNO3 added to the total volume of solution. It's 7:20. Did I set an alarm for 7:20? When did I do that? One more hour, gang. Seven, right? No, it's 8. We're moving to 8. Thin layer chromatography. Ugh. Moving to the 5, 6, 7, 8. It should be the sample caffeine pure. Since your oral exam is about, let's wrap up the final summary. This experiment is departure from your previous titration, moving to quantitative analysis to semi-quantitative and qualitative. Identifying what is there. So we're going from quantitative to qualitative. That's a term. That's a terminology. Stationary phase, you get a silica gel. The 60 refers to the pore size. Mobile phase, a mixture of cyclohexane, ethyl acetate, acetic acid. Chamber saturation, the TLC chamber was lined with filter paper to ensure the atmosphere was saturated with solvent vapors, which prevents the solvent from evaporating off the plate during development and ensures a straight solvent front. Chamber saturation, TLC chamber is lined with filter paper to ensure the atmosphere was saturated with solvent vapors, which prevent the solvent from evaporating off the plate during development and ensures a straight solvent front. Detection: why UV light? Most organic molecules like ASA and caffeine are colorless. Fluorescence quenching: the fluorescent indicator in the silica gel makes the whole plate glow green under 254 nanometer UV lamp. Visualizing the spot: ASA and caffeine molecules absorb UV light at this wavelength. When they are present on the plate, they quench the fluorescence of the indicator, appearing as dark spots on the glowing green background. Okay, 7:30 alarm at 7:30. I get it, but 7:20, I don't really understand. Fluorescence quenching. Okay, okay. Last one. Let's look at the last one and redo it. Recheck it again. Cause I'm stupid. I might say some stupid shit when in the during I'm doing when I'm doing the oral exam. I might say, "Oh, is that how it works? I did not know that." Your final review before the oral exam. Here's the breakdown of the determination of iron content using UV spectroscopy. This experiment is unique because it uses light absorption rather than chemical titrant to quantify the analyte. The aim was to determine the concentration of iron in an unknown sample by forming a color coordination complex measuring its absorbance with spectrophotometer. No, don't open GPT. It was a mistake. God damn it. Quit. It's a mistake, gang. I don't. For your final review before the oral exam, here's a breakdown of the determination of iron content using UV spectroscopy. This experiment is unique because it uses light absorption rather than chemical titrants to quantify the analyte. The aim was to determine the concentration of iron in an unknown sample by forming a color coordination complex, measuring its absorbance with spectrophotometer. Aim was to determine the concentration of iron in an unknown sample by forming a color coordination complex and measuring its absorbance with a spectrophotometer. To get an accurate measurement, you had to perform two chemical steps before reduction. You added hydroxyl ammonium chloride. Its job is to reduce Fe3 plus in the solution to Fe2 plus. This is vital because the coloring agent only reacts with iron in plus 2 oxidation state. Complex A. Oh, that was the same case for experiment number 4. Was it 4? God damn it, I don't know the names of the experiment though. No, it's not 4. So it's either 2. Which one had iron? No, that's not 2. Take 2 is nickel. 3, come on. I gotta name these because if I didn't, it's gonna be fucked up. It's experiment number 3, determination of Fe2 plus in chloride containing solution by manganometric titration. That's where you had to add sodium metabisulfate to, yeah, it was sodium metabisulfate to reduce iron. Oh god. I should get my coffee because I think that's why I'm not like, come on. But is it good to depend on stuff like these? Mm. Stupid ass ads, bro. Stupid. You know what? I got an idea. I'm gonna go to the university. I'm just gonna be there, wait till my appointment time is up. I'm gonna bring this bad boy, my laptop, cause I need a digital copy of all the reports I submitted. YouTube, I need to drink a coffee, gang, cause I can't keep my eyes open. Like, that's so weird. It's like the starting of the day. Like, it's the morning. What? It's the morning and I'm feeling like this. That's stupid, gang. Peace out, YouTube.